SEVENSTAX, Embedded Technologies.
Hi, welcome to this short introduction to the SEVENSTAX V2G Conformance Tester. This video will give you an overview of our Conformance Tester, its features, and the implemented V2G conformance testing specifications, as well as the user interface. Let's start by having a look at the SEVENSTAX Conformance Tester deliverables that you as a customer will receive from us. On the right, you see most notably a laptop computer, which is pre-configured with our test software shown on the left. This testing application facilitates testing through creation of profiles, a test result database, mapping of requirements, and more. The laptop is also equipped with the possibility for remote maintenance access in order for us to diagnose problems together with the customer. Right next to the laptop, you can see a small black box, which is the second hardware component of our conformance tester, our PLC modem. To understand what the PLC modem does, let's break down how the tester works internally. The test software on the laptop includes the test executables that are based directly on the testing specifications of the ISO and DIN standards. On top of this, we have a web application which facilitates managing and running test profiles, access to test results, and so forth. And here we find the PLC modem again, our small black box from earlier. It acts as an interface connecting the laptop to the system under test, enabling the test executables to interact with your product via the control pilot line of a charging connector. This includes the low-level communication using CP state changes and PWM, as well as the high-level messages over PLC. So, which test specifications does our conformance tester cover? Currently, we offer the DIN 7122, the ISO 15118-4, the -5, and the -21. Each of these test suites is available for EV as well as for EVSE. To support more flexible workflows in the near future, we are building a customization toolkit. It will allow you to extend the official test suites by creating your own scenarios using our core data types and EXI implementation. This way, you can conduct highly specific testing throughout your development cycle. More details on this new feature will be coming soon. Now that we have covered all the basics, let's have a closer look at the testing application. It can be accessed through a web browser and lets you create and store different test profiles, execute them, or browse through test results from previous runs stored inside a database. While a test is running, you are presented with an extensive visualization of its progress. After a test run is finished, the GUI lets you analyze and export the results. For even better usability, we offer the cruise control mode, which lets you run test cases completely independent of their requirements and configuration. You simply select a set of tests you want to execute, and our software takes care of configuring the test system and provides a configuration file to set up your application according to the preconditions of each selected test case. Additionally, the testing application's command line API lets you load and run test profiles without using the GUI, enabling you to fully integrate the conformance tester into your automated CI testing setup. But all theory is gray, so let's dive into a quick demo of our testing application. For this demo, I am running the conformance tester against a system under test that is simulated by software locally rather than an actual hardware EVCC or SECC. To do this, I am using a virtual Ethernet interface instead of the PLC modem, but I will get into this feature in a moment. This is the dashboard of our testing application. At the top, we see the test profiles. On the bottom, we see the test results database. On the right, we have a list of the test packages that are currently activated on the system. I have already created a profile as a defined set of test cases for this demo, but we will open it in editing mode first to show you the different steps of creating a new profile. At the top, we can already see the process laid out as tabs for the different configuration steps, resulting in the selection of test cases. The first step is selecting which kind of system under test we want to test. There is a choice between EV or EVSE. In this case, let's pick EVSE. Then we choose the specification according to which we want to test. Let's go with the ISO 15118-2 standard for now. We can also set the logging level and the interface to the system under test. This is where we can decide to either test via the PLC modem or an Ethernet interface that could even be a virtual one. While testing high-level communication via Ethernet can be very helpful during development, the PLC modem is needed to fully qualify a product, as it allows combined testing of high-level and low-level communication, like control pilot and PWM signals. The aforementioned cruise control mode can also be enabled on this tab. By pressing Continue, we proceed to the specific configuration required by the standard we selected. Most of these parameters come directly from the DIN or ISO standards respectively. We can scroll through the complete list or search for a certain parameter to modify it. On the next tab, we have the option to set specific timers that are not part of the specification but are relevant for test execution. For example, we could set a wait time after execution of a test case has finished to allow the system under test to reset. In the next step, we can configure charging parameters for the charging session, since those are freely adjustable in the scope of the test cases. After all parameters are configured, we get this list of all test cases. The system automatically matches the configurations we just made to the conditions of each test case and marks those test cases that can be executed with our current configuration. We can now simply tick the test cases we want to be executed with the profile we are creating. In the list, we also see test cases which are not available with our current configuration. While we cannot tick those for execution, we can select them to see their details here on the right. These details include a test case's description, the requirements it covers, as well as the configuration needed to execute it. For example, if we would like to run the test case Service Discovery 002 in the AC variation, we can click on it and see which parameters need to be configured for this test case to become available for execution. For convenience, we can also hover the cursor over the referenced requirements to check out their descriptions without having to look them up in the specification documents. Once we have finished our selection of test cases, we save the profile, which brings us back to the dashboard. So now let's run our test profile by clicking on the small play icon next to it. This brings us to the main view of the Conformance Tester system, where we can execute test cases and track their progress. On the left side, we can see the test cases we just selected during the creation of this profile. We can click on the small info icon next to each test case to have another look at the details we saw during the creation process. Once we are ready, we click the Launch Test button to run this suite of tests. On the bottom of the screen, we can now follow the progress through the different stages of each test case as it gets executed. This is especially useful for longer test cases consisting of a larger number of steps later in the charging session. While the other test cases are still running, we can already have a look into the output log files of those test cases that did already finish. To do that, we click on the log file icon of the first test case, which opens a new tab showing the specific output of this test case, so we can check what went wrong or right during its execution. As an example, let's take a look at one of the failed test cases. We open the log file to find out why the test failed. In most cases, those outputs are enough to understand what the problem was. In our example test case, the text states that the sum of the individual time intervals did not match the period of time indicated by the EVSE, so there was a miscalculation of the system under test regarding schedules. As you probably saw, I clicked on this emergency icon here to jump directly to the error message in the log file. Generally, the log file shows all incoming and outgoing messages as well as every started or stopped timer. Depending on the verbosity level that we chose, we can also track the matching progress and exactly which part of an incoming message did not match the template expected by the test. Here, for example, we can see how the charge parameters of an incoming message were verified. Now we can check for each parameter if it matched. This matched, this matched, this matched. So the message itself matched the expected template, but there was an error in the calculation of the intervals later on. This test case, for example, also failed, but the fail message invalid data content is a bit more ominous. Let's look into the matching section of the output file again. We see the incoming message here, and it looks like everything matched at first. Notification matched, signature not existing matched. But here the response code was not no charge service selected, but instead it was service selection valid. And this mismatch caused the test to fail. In general, the process for tracing errors in the conformance tester involves looking at the output of the test itself, looking into the mechanics of matching packages, and also looking into the packet dumps using Wireshark if needed. To access the PCAP files containing the packet dumps that were recorded during execution, we simply click on the small Wireshark icon next to a test case. This directly opens the corresponding PCAP for this test case in Wireshark, where our own packet dissector called SEVENSTAX GreenShark will help you to visualize and understand the charging communication that has happened during the test run. For more information on GreenShark, check out the link in the video description. We can also rerun selected test cases if we want. So if we are in the development process and want to see if a change that we made did fix an issue, then we can rerun the affected test case here from the GUI. This creates a duplicate results entry, so we are not invalidating the first result, but adding a second test run for this same test case instead. This second run gets marked by a small rerun label. If we are finished with our test campaign, we can save the results into our database. We can also export the results, which gives us a zip file containing all of the test case outputs, the packet dumps, and a summary of the results. This archive also includes everything you need to decrypt the TLS traffic if needed. Optionally, we can configure a JUnit export. From the dashboard, saved results can be loaded back into the same view that we used during testing. Here we can interact with the test results the same way we did before to continue work on them or look for details we might have missed earlier. This concludes our quick introduction into the SEVENSTAX Conformance Tester. Thank you for watching. If you found this video helpful, feel free to like it and follow our channel to help us address more people.